Hello everyone. Now I am going to explain you about a basic construction and operation of a binary adder and subtractor circuit. Okay. So here if you want to perform some micro operations, arithmetic micro operations on two registers. Okay. So which are known as arithmetic micro operations. So here I am performing that micro operation as addition and subtraction on two registers. Suppose consider register 1. So in that register I am storing the register A information, and consider register 2. In that I am storing the register B bit information. So on that register A and B, if I want to perform addition, if I want to subtraction, okay. So here by using a one common mode bit, here I am designing a one circuit which performs addition and subtraction on that binary numbers, which is known as binary adder and subtractor. Okay, so already in the last video we discussed it, right? The binary adder is constructed with the help of a full adder circuits. Okay, the similarly here if we want to construct a subtractor circuit, we can construct that with the help of a XOR gates with the help of full adder circuit. So as we know now, the full adder circuits which works with the two operands with the previous carry results in a sum and carry out. Okay, so it works on three inputs, gives a two outputs as a sum and carry out. These carry again works as a previous carry to the next higher order full adder circuits. Okay, so here coming to the XOR gate. So this is the basic symbol of an XOR gate. So it will takes the two inputs A and B and gives the output as A XOR B, nothing but A into B bar plus A bar into B. So it can complements the subtract, okay, it can complements the one bit information and add one to it, which is going to gives the output as subtraction process. Okay, so first of all we'll see the basic truth table of an XOR gate. So here we are taking a two inputs as A and B. So here for two inputs we have four combinations 0 0 0 1 1 0 1 1. Okay, so if A bit is 0, B bit is 0, here what is the operation we have to perform? A into B bar. So we have to complement this B bit information. So this will become what? 1 0 1 0. Multiply this B bar with the A value. So here if A is 0 and whatever may be the B value, okay, so that will become 0. A into B bar is 1 0. A into B bar is 0 0. A into B bar is, here B value is 0 and it is complemented, so it will become 1. 1 into 1 becomes 1. Similarly here A is 1, B bar is 0. 1 into 0 becomes 0. Similarly we can perform A bar B. So first of all we have to complement the A bit information as 1 1 0 0. So if it is 1 1 0 0 get multiplied with the B bit, 1 into 0 is 0. 1 into 1 is 1. 0 into 1 is 0. 0 into 1 is 0. Now we have to add these two. So which will gives you 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 0 is 0. So from this truth table, so we have to remember one thing, that here if the both the inputs are same like 0 0 1 1, the output is low, nothing but 0. If they differ like 0 and 1 or 1 or 0, the output is high. Okay, so with the help of this XOR gate and full adder, now we are going to construct this binary adder and subtractor. So this is the basic block diagram of a binary adder and subtractor. So here I am explaining this operation addition and subtraction individually. So this is the adder. For adder and subtractor I am taking the same circuit. Okay, here I am changing the conditions here. So this binary adder and subtractor, here we are performing some operations like addition or subtraction on 2 bits. So therefore here I am taking a 4-bit information like A0, A0, A1, A2, A3 as register A information, B0, B1, B2, B3 as register B bit information. Okay, so with the carry as, so we can take the 4 full adder circuits. So for full adders, A bit, B bit input, C0 as input results in sum and carry out. Okay, so this will be C1, C2, C3. Similarly, for 4 bits, here we have to take 4 full adder circuits. So here the common input is here the mode bit or control bit. So if the mode bit is 0, this circuit works as an adder. If mode bit is 1, this circuit works as a subtractor. Now we will see that. So the first case here I am taking the mode bit as 0, and this mode bit is one of the input of the XOR gate and again input for the carry, previous carry. So C in 0 or C naught is 0. Okay, so here first of all here we have to consider the first full adder as 0 bit full adder, so which has a naught bit as input, carry C naught as input, and here XOR of the mode bit and control bit as a one more input. So here we are taking XOR operation of mode bit with a B bit information. If it is 0th full adder means it will be B0, first full adder means B1, second means B2, third means B3. Now we will see. So what is XOR of this M with the XOR B means M into B bar plus M bar into B. So here what I have to perform? I have to perform addition operation. Addition on this A bit and B bit. So what I am giving here? Mode bit as 0. This mode bit again connected back to a 0th full adder of the full adder circuit. So if mode bit is 0, this carry is 0. Here A naught bit is directly connected to full adder, B naught bit is connected to XOR gate. Here mode bit is 0. So what is output of this XOR gate? 0 XOR with B bit information. So here 0 XOR with the 0 it means B naught bit information. So here M into what is its output? M into B bar. So here M is 0 with the B bar is B naught bar. Similarly M bar into B, here M is 0, its complement is 1 into B naught bit means here it is B naught. So for first full adder we are getting output as B naught. Similarly, this second full adder we are getting this as B1. So here it is B2 and here it is B3. So therefore first full adder, 0th full adder, the inputs are A naught bit, B naught bit, C in. So what is the sum here? A naught plus B naught plus C naught. Similarly for S1, so this is the input, one more input is B1 because XOR is what here M is 0 and B bit information is 0. XOR with B means here we are getting the output as B bit only, means what here it is B1. So sum is A1 plus B1 plus C1. Similarly it is A2 plus B2 plus C2, A3 plus B3 plus C3. So therefore here we have to come to one conclusion that if M is equal to 0, the sum will be A plus B plus carry in. So which is nothing but addition operation. Okay. So likewise here we are going to check for subtraction operation. So for that purpose here I am taking the same circuit diagram as mode bit as 1. Okay, so this is the same circuit diagram, 4 bit information of 2 bits A bit and B bit. So here consider 4 full adders with A bits are directly connected to full adder, B bits are connected with an XOR gate. So for subtraction what you have to do for subtraction? So here if this is a one register, so first of all we have to take the first register, we have to add the second register complement of it plus 1. So means what? 2's complement of subtrahend which is added to minute, nothing but gives you a subtraction process. Okay, now we will see that how the subtraction is done. So here what is the control bit or mode bit? If the mode bit is 1, that is connected as carry here. So here full adder has a input of A naught B naught, which is XOR with the mode 1. So here what is the XOR bit information? It is M XOR with B. So M is 1 means here M into B bar plus M bar into B. So M is 1 means 1 into B bar plus 1 bar is 0 into B. So what is output here? We are getting B bar. So means what? M is equal to 1 means 1 XOR with the B bar, we are getting output as B bar. So for 0th full adder, the output will be B naught bar. For first one, B1 bar. Second one, B2 bar and B3 bar. So here full adder means what? It simply adds the 2 bits, A bit information, this B naught bit information with a carry. So what is the S naught here? A naught plus, this is what is output here, B naught bar. What is the carry here? M is 1, right? So therefore here. So what is this information? Register 1 information. R2 is complemented, 1 is added, nothing but. So it is simply a subtraction of A minus B. So similarly, FA1 means what? Here what is the output? S1 is A1 plus B1 bar plus previous carry. A1 plus B1 bar plus previous carry. Similarly, S2 is A2 plus B2 bar plus previous carry. A2 plus B2 bar plus previous carry. S3 is A3 plus B3 bar plus. So by this way, based upon the mode signal, if M is equal to 0, it perform addition. If M is equal to 1, it perform subtraction. So therefore, it is a circuit which performs binary addition and subtraction based upon the mode bit. Thank you.